Physiologically means functionally. May be similar or dissimilar. Okay, so this is what isogamy mode of reproduction, that is most easiest way of sexual reproduction found in kingdom Protista. Okay, now next type is anisogamy. Here what is that? Anisogamy. Anisogamy. In this mode of sexual reproduction, both the gametes are dissimilar in nature and physiologically also have dissimilar. Okay, so this is anisogamy. Okay, usually mostly it is having dissimilar, but exception also there, that is having similar. So what we can say, or rarely similar, but the structure, shape, size, gametes are dissimilar. Okay, now next one is oogamy. Next is oogamy. Okay, oogamy means in this mode, male gamete is small and having motile in nature, movement in nature, while female gamete is comparatively large and non-motile in nature. Okay, so this is the mode that is found in the kingdom Protista, oogamy. Okay, now this mode of sexual reproduction, that isogamy, anisogamy, and oogamy. Okay, here what happens, male and female gametes takes place, the formation of male and female gametes takes place in specialized sex organs. So what we can here, male and female gametes are formed in sex organs. Okay, so these are the mode of reproduction. Now this kingdom Protista, generally from birth to the death, okay, they are known as life cycle. So this life cycle found in Protista having two types. One is known as zygotic meiosis and one is known as gametic meiosis. So come on that life cycle of protists. It is of two types. Okay, what are the types are there that we have to see? So life cycle in kingdom Protista having two types. One is life cycle that is showing a zygotic meiosis. So first we have to see life cycle showing zygotic meiosis. Okay, life cycle showing what? Zygotic meiosis. Here what happens? Just graphically I am saying adult having haploid in nature. What I told? Adult having haploid in nature. And what happens? Here mitosis occurs. Okay, here what happens? Mitosis occurs. And two haploid gametes formed, male as well as female. So two haploid gametes are formed. Then what happens? Fertilization occurs. Fertilization occurs, and these fertilization found what? Zygote. These are forming zygote, and this zygote is 2n. Okay. Now, then again what happens? In zygote, meiosis takes place. Meiosis takes place. Since meiosis occurs in zygote, that's why known as what? Zygotic meiosis. Okay. And most of the time, the phases found is in haploid nature. That's why it is known as haplontic life cycle. What is found? Haplontic cycle, life cycle. And where it is found? This is zygotic meiosis. Now, in the examination, they will remove either fertilization, they will remove either zygote, they will remove either haplontic life cycle, and they will ask medical question that fill the appropriate word with the blanks. Okay, so that options you have to see and do your answer. So this graphs are very important. Okay, so this is what life cycle showing zygotic meiosis. This you have to elaborate. What I told, when protist is haploid, adult they see. So come on that. When protist adult is haploid, that is N. Okay, haploid means N. So haploid and meiosis occurs in zygote, and meiosis occurs in zygote. Okay, and meiosis occurs where? In zygote. Then it is known as what I told, zygotic meiosis. Then it is known as zygotic meiosis. Okay, So then it is known as what? Zygotic meiosis. Okay. Now, what I told, mostly in this life cycle, haploid phases are present. Okay, only diploid condition is zygote, and that's why it is known as haplontic life cycle. So what I told, in this life cycle, most of the stages are in haploid condition. Haploid condition, and only zygote is in diploid state, and hence it is known as haplontic life cycle. Understood that what I told? Okay, only which one is the diploid? Only zygote is in diploid, means 2n, and rest is n. Okay. Now, next type is, and example if we are seeing, so for example we can take, for example, dinoflagellates. Okay, dinoflagellates. Okay, now next we have to come on that second type of life cycle, that is gametic meiosis. So life cycle showing gametic meiosis we have to come. Now, life cycle showing gametic meiosis. Okay. Now, if we are seeing gametic meiosis, so here what happens? What we have to see? Same thing, but here adult will be in diploid state. So, adult is what? In diploid state, and here instead of mitosis, here what will happen? Meiosis occurs. Here meiosis and forming of two gametes. Okay, forming of what? Two gametes, one is male, one is female, and again fertilization occurs. Here what happens? Fertilization, then same zygote formation occurs. Okay, and then what happens? Then mitosis occurs. In here what happens? In zygote, mitosis, or we can say growth, occurs, and that confined to what? Adult, that is diploid. So here what happens? Gametic, this is known as gametic meiosis. Now, if you are seeing this, most of the phases are in diploid stage. That's why it is also known as diplontic life cycle. Diplontic life cycle. Okay. Now we have to elaborate this graph. Same thing. Any, maybe this one will be disappear, this one will disappear, and they will ask question, fill the blank with appropriate options. So you have to give attention on that time. Okay. Now come on their illustration in gametic meiosis. Now, in gametic meiosis, what we seen here, protist body is adult body is diploid, and meiosis takes place during gamete formation. So, what we can say here, protist adult body is diploid and meiosis takes place during gamete formation, and hence known as gametic meiosis. Okay, in this life cycle, most of the stages are found as diploid state. Okay, diploid state, and hence it contain diplontic type of life cycle. Okay, so this is having what? Diplontic type of life cycle, and that is gametic meiosis. And in zygotic meiosis, what is found? Haplontic type of life cycle. Okay, so now you understood that these two type of life cycle are being formed. Okay, now this diplontic type of life cycle mostly found in which group? That is diatoms. So what we can say, for example, diatoms. Okay, now till yet we discussed reproduction and their life cycle. Now we have to see what are the forms mostly they are having, that we already know. They may be decomposer, they may be photosynthetic, they may be parasitic. Okay, and under parasitic they may cause many diseases like dysentery, like malaria, like sleeping sickness. Okay, so we have to see in mostly these are photosynthetic, saprobic, or parasitic. And under parasitic, it may cause diseases like malaria, dysentery, sleeping sickness, etc. Okay, so this may cause, mostly these are photosynthetic, saprophytic or saprobic, or parasitic. And if parasitic, it causes disease like malaria, dysentery, sleeping sickness, like that. Okay. Now come on their groups one by one. So first we will discuss under kingdom protista what the groups or organisms are there, that is chrysophytes. So come on that. Now one by one we will discuss. First is what? Chrysophytes. Okay. Now these chrysophytes, most important organism that contains are diatoms and golden algae. What I told? This group contains diatoms and desmids, and desmids commonly known as golden algae. Okay, so diatoms and desmids are there. Desmids are known as golden algae. Now, mostly the organisms belongs to chrysophytes found in fresh water. Where found? Fresh water and sometime marine water. So what we can say? Mostly organisms belongs to this group found in fresh water and some are in marine water. Okay, so some are found in fresh water and some are found in marine water. Okay, now mostly they are planktonic. Now planktonic means passive swimmer. The wave are going in that direction, these organisms also moving in that direction, so that is known as passive swimmers. So mostly these are planktonic. These are planktonic, that is passive swimmers. Okay, so mostly these are what? Planktonic or passive swimmers. Okay, so this you have to remember that mostly these are planktonic. Okay, and which groups they are having? Diatoms or desmids, or what we can say the group name chrysophytes. Okay, now these are mostly photosynthetic in nature. So what we can say? These are photosynthetic, means they are making their food by own. They are photosynthetic in sorry they are photosynthetic in nature. Okay, so these organisms doing what? Photosynthesis, making their food by own. So they are photosynthetic in nature. Now these diatoms contain cell wall and that looks like soap box. Now we will see that. diatoms containing cell wall looks like soap box. Now they are looking like this. Okay, so soap box we are seeing. So this is look like soap box. Now question already asked, the cell wall looking like soap box belongs to. So that belongs to what? Diatoms. That belongs to what? Chrysophytes. Okay. So diatoms having what? That cell walls looks like soap box. Okay. Now this cell wall containing silica, cell wall of diatoms containing silica. Okay, they are containing what? Silica, and hence this cell wall is indestructible in nature. Indestructible in nature. Okay. Question is there, cell wall of diatoms is indestructible due to presence of silica. Okay. Now, since this silica forms cell wall and they are, just see that this is forming, another this is forming, another this is forming, okay, another this is forming, just like soap like box. Okay, so these like they are forming with the help of what? Silica. So all are having silica, and it is also what having? Indestructible. So due to indestructible nature of cell wall of diatoms, it forms a layer, big layer in the bottom area of C and known as diatomaceous earth. In very long time, these cell walls settle down in C and forms diatomaceous earth. Okay, so diatomaceous earth are found in, where it is found? So that is found in diatoms, or we can say diatomaceous earth are made up of. So that is made up of what? Same. That is made up of diatoms cell wall, and this contain silica that is indestructible in nature. Okay. Now this diatomaceous earth, due to containing of silica, having industrial use. What are those? Since these diatomaceous earth containing silica, so this happens what? Granular or granules like structure. Okay, and since granules like structure are there, so these are shining creating. Okay, so they are producing what? Shining. Now commercially what the purpose they are using? So used in polishing, filtration. Okay, filtration of what? Oils and syrups. Homeopathic you are seeing, homeopathic bottles are there or wine bottles are there, that is shining. Okay, so what we can say? commercially these are used in polishing and filtration of oils and syrups, etc. Why? Due to its gritty or shining nature. Okay, what is that? Due to what property? Gritty nature or shiny nature. Okay, now as we already discussed that most of the ocean's bottom are containing what? Diatomaceous earth, and these are what? Photosynthetic in nature. So diatoms are known as chief producers in the oceans. Diatoms are also known as chief producers in the ocean. Okay, this also you have to remember, which is known as chief producers in the ocean. So that is known as diatoms. Okay, because these diatoms doing photosynthesis, and photosynthesis means they are making their food on, and making food means producers. So that's why these diatoms are known as what? Chief producers of the oceans. Now, if diatoms quantity will increase, so that indicates that pollution level is decreased. Okay, so what I want to say, these are good indicators of water pollution. Diatoms are good indicators of water pollution. Okay, this also the question asked in JIPMER, which acts as good indicators of water pollution. So this is diatoms. If air pollution asking, so lichens are there. Lichens are good indicator of air pollution. And for water, it is water pollution indicator, good indicator is what? Diatoms. Okay. Now, if we are coming on the common examples, so common examples of these chrysophytes, or we can say diatoms, are triceratium. So come on that common examples. What are those? Common examples of diatoms are, what are those? First is a triceratium. Okay, diatoms common example is what? Triceratium. Next is Melosira. So Melosira. First is Triceratium. Next is Melosira. Next is Navicula. Navicula and Cimbella. Question directly asking diatoms common example. Sorry. So this you have to remember. First is Triceratium. Next is Melosira. Next is Navicula. Next is Cimbella. Okay. So under chrysophytes, what we discussed first,